Okay. For the agenda of my presentation, first, the problem the seafood value chain face and the scale of this problem. After the two options we had more than 3 years ago at the beginning of the project. And next, the option we recommended. And I try a quick demonstration challenge. And finally, a few concluding words. Okay, what is the problem seafood trade value chain face as other food chains? Traceability becomes a key purchasing criterion and will be increasingly. However, traceability is mandatory for food products in Europe for a long time. There are multiple directives and standards in this field. Anyway, companies did not wait for Seafood Tomorrow to meet their obligation, but they did it individually, company by company, what we call internal traceability. Either thanks to local IT systems or manually, Excel, or even by using paper registers. However, the need for traceability lies at the level on the entire trade chain, from end to end, from producer to consumer, what we call external traceability. Therefore, there's local internal traceability devices are not linked together. It's the main problem. We did not have precise figures concerning the number of actors of seafood market sector. In France, for the fish part, there are about 3,000. If we add the mollusk sector, more than 80,000 are reached, including a large number of outlets which may have needs of traceability information. I don't want to extrapolate those figures to the European market, but on that basis, I think this number of 100,000 is not overestimated. In case of sanitary concern, the withdrawal of products take too much time, especially due to the fact internal traceability systems are not linked together, as I have explained before. PREDELL has developed similar system in France, for example, in the poultry sector. Thanks to it, crises like current H5N8 influenza, the authorities can anticipate and the faster and more targeted response is possible. Thus, fewer animals are slaughtered. What's the option? The first is traceability based on blockchain architecture. Each company is a value chain. Of a value chain would be a node of a network. It's a totally peer-to-peer redundant decentralized network, meaning each node holds the data of all the transactions carried out since the setup time of the blockchain, meaning a huge quantity of data at each node. 3 years ago, at the beginning of Seafood Tomorrow, there were pros and cons about blockchain. There were a lot of communications about blockchain architecture since the Bitcoin phenomenon, especially in the world of finance. Applied on supply chain concepts, there were some concerns. Technical complexity due to the quantity of data that I mentioned at every node of the network. We had to remember a lot of actors are very small enterprises with only 1 or 2 PCs. I mean also business roles often change and the mechanism of their distribution is complicated. At this time, there were also some concerns relating to who is allowed to see what data, question of confidentiality. Since we have been advances in the coverage, advances and visibility of this point, but again, 3 years ago, it was not the case. The second option was a traceability system based on cloud architecture. It is very simple and more classical. We have a centralized and internet accessible system. It's why we say on the cloud. And the companies of a supply chain feed it with their data. We have developed systems based on this architecture, which are often used for traceability, and that works. All the data are held by and managed by central systems. It is easy to apply and deploy the management rules on the systems. It is clear that cloud architecture have a long proven track record. The downside is they are a little bit less innovative. Nevertheless, it will be technically possible to migrate to blockchain, and why not add artificial intelligence, who knows. Our recommendation 3 years ago, in the light of the above criteria, we recommended option 2 based on cloud system. For both sectors, aquaculture and capture, this regulation established community control system, regulation 1224/2009, community control system for ensuring compliance with the rules of the common fishery policy. In terms of cost, medium and big companies only need to extract their data and send them to the clone. Data of the batch of fish, the production they have. For small data, they use an existing PC or tablet to keep their data. It's what we are going to see in the next slide. Companies send data to a Seafood Tomorrow system automatically through computer-to-computer exchanges, what we call EDI, represented by red arrows. It is well-known practice in any industry for medium and big companies having a large volume of data. For small companies, keying is very simple and an easy way to feed the system. It's a blue arrows on the schema. By the end of the value chain, companies include a QR code on the label of the product, so the consumer can scan it and get product and traceability information. The system is multi-languages. Today, there are 6 languages, but to add a new language demands only 1 or 2 hours. To switch the language, it is only necessary to change the language option of internet browser, both on the computer and the smartphone. As a demo, I propose the following business case. Premier, a farm as product batch fish P1. Malomar, a second farm as product a batch of fish M1. Premier is also something like integrated company. It is also a transformation company which has product the batch of fillet P1, P11, sorry. Atlas, Delmar, second transformation company, has produced D1, the final product. Finally, as a consumer, I will scan this batch to get information. Conclusion, I think it's a complete system for all the actors of both architecture and capture value chain. Assessment by testing companies we provide, easy to use after some adaptation concerning the quantity of mandatory data. We diminish the mandatory data. And by the end, the key success factor is the adoption, and probably the question of the after seafood tomorrow. That's all.